We're going to talk about exploring data.
Here's chapter 2, exploring data with tables and graphs. Given the frequency table, answer the following questions. Part A, the number of classes in the table is. As you look at this table, on the left side, you see the limits. The very left column, it's considered to be the lower limits. Next to it is the upper limits. And next to it is the frequency, the numbers. For example, the age between 11 and 20, there are 5 of those. That's the meaning of it. So how many of those classes do we have? 1, 2, 3, 4, 5. That would be the number of statistical age groups defined, number of classes. The next one is asking for the class width. In order to calculate the class width, when the limits are given, all you have to do, pick up 2 classes, 2 consecutive classes. You can look at their lower limits, 21 minus 11, or upper limits, 30 minus 20, 41 minus 31, 60 minus 50. So in this case, it becomes 10. The class width is 10. If we were to look at one class, for example, if you look at the first class, then upper limit minus lower limit plus 1 unit. The unit may be in thousands or in decimals like 0.1. So if you're looking at the limits, the upper limit minus the lower limit plus 1 unit. So for example, 1 class. So you want to distinguish between the 2 processes. However, if you're looking at, let's say, these 2 consecutive, 60 minus 50, the class width is 10. The midpoint of the 4th class. In general, the midpoint is the sum of the limits divided by 2. So if I wanted for the first class, add these 2 numbers. Second one, add these 2 numbers, so on and so forth. So for the 4th class, I need to add 41 and 50 divided by 2. 41 plus 50 divided by 2. So the answer is 45.5. The lower boundary of the 5th class. In general, when you want to find the boundaries, you look at the upper limit of one class, lower limit of the next one. For example, these 2, we add them up, divide by 2 would be the upper boundary for the first class, lower boundary for the second class. Now, if we want the lower boundary for the 5th class, we are going to put these 2 together, add them up, divide by 2. So this 250 plus 51 divided by 2 clearly is 50.5. So midpoint of the upper limit of 4th class and the lower limit of the 5th class. That's how you calculate the boundary. And this would be the boundary for both upper boundary of the 4th class as well as the lower boundary of the 5th one. The upper limit of the first class. First, notice, generally speaking, these are lower limits and these are upper limits. So we want the upper limit of the first class, that would be number 20. Upper limit of the first class. What is the sample size? Look at the frequency column. Sample size N is the summation of those, summation of X or summation of X sub I as far as the mathematical format. So add those numbers. So the frequencies are 5, 6, 9, 11, 4. Add them up. They result in number 35, sample size. The next one is asking for the relative frequency. of the first class. By definition, relative frequency, or short RF, is the frequency of that class divided by n total size. So for the first one would be 5 divided by 35. For the second one would be 6 divided by 35, so on and so forth. And as always, any fraction has to be put in its lowest term. Therefore, 5 over 35 for the first one is 1 over 7. If you want to go with percentage or decimal, you want to carry enough decimals, or you want to see what the question is asking you. We're going to continue here. What I'd like to do is to show you how you can simplify what we just did using a table. This table was given, and we showed the class width is 10. Just pick up any two consecutive classes, 41 minus 31, for example. So we have the width, and the boundaries are the midpoints between the upper limit of one class and lower limit of the next. So what I'd like you to see is the following. So this is given. So I wanted to show you all of that. What would be the midpoint for all of them? And knowing the width is 10. If you calculate the midpoint for the first class, 11 plus 20 divided by 2, which is 15.5, then all you have to do, add the width. Notice 15.5, add the width, 25.5, 35.5, all the way to the end. You don't have to calculate the midpoint anymore. Just keep on adding the width. As far as the boundary goes, the same thing. If you add up these two, 20 and 21, divided by 2, you get 20.5. Therefore, they result in 20.5. The next easy step is to use the width. Keep on adding the width. So 30.5, then this one repeats, 40.5. This one repeats, 50.5. So I hope you realize there's not a lot of calculation as long as you can calculate this. Now, what about the lower boundary of the first class? You subtract the width. 20.5 minus 10 gives you 10.5. As I mentioned regarding the relative frequency for the first class is a 5 divided by the total size n, which was 35, and it's 1 over 7. Now the next one is 6 over 35. I want you to simplify it when you can. And the next one is 9 over 35, 11 over 35, 4 over 30. So I just wanted you to see the whole thing in one shot. The next one is asking to find the model class. The model class is the one with the highest frequency of occurrence, which is 11, therefore makes it class number 4, from 41 to 50. And to find the mode, you just look at the midpoint for that. So here's the class, simply because it has the largest frequency. So what is the model class? Look for largest frequency. Class number 4 from 41 to 50. And what is the mode? The mode is the midpoint of that class. So the model class is number 4 because it has the largest frequency of 11, and its midpoint is the mode. The following frequency table describes the speed of drivers ticketed through a 30-mile-per-hour speed zone. We want to calculate the relative frequencies for all classes. There is nothing new here. We learned how to find the relative frequency, simply RF. So you have to RF, or relative frequency, is F over N. So we have to divide these numbers by the total size. So let's calculate the total size N. So first, this is the definition of RF, relative frequency. Then we add 25 to 14, 7, 3, 1, and we get 50. So add up these numbers. The result is 50. So what is the relative frequency for the first one? First class would be 25 divided by 50, which is, of course, 1/2. The next one, 14 over 50, 7 over 50, all the way to the end. And as always, you want to simplify it when you can. For example, 14 over 50 is 7 over 25, 25 over 50 is 1/2 relative frequency. What percentage represents the speed of 53 miles per hour or less? So you look at your speed column and look for 53. So anything less than that, right? All the way from 42 to 53. That's the idea. And you have a choice. You can add up these three numbers, divide by a total size because we want the percentage in essence. Or you can add up these three numbers, the relative frequencies, and change it to a percentage. So we are looking at the first three. So add up those three numbers or add up the frequencies divided by 50, change it to a percentage accordingly, and it gives you about 92%. We want to find the boundaries. And remember what I mentioned. First of all, the boundaries has this definition, or the midpoint between the upper limit of one class and the lower limit of the next one. So if you put these two together, 45 and 46, the midpoint is 45.5. So this would be the upper boundary of the first class as well as the lower boundary of the second class. Now, what is the width? The width is 4. Why is that? 46 minus 42. 57 minus 53. Pick any consecutive, or 45 minus 42 plus 1 unit. So you can, for example, say 46 minus 42 or you can say 45 minus 42 plus 1. Either way, it gives you number 4. Now that it's 4, all you have to do, add 4. So this becomes 49.5, and you move on. And the lower boundary of the first class becomes 45.5 minus 4, which is 41.5, and you can figure out the rest. So the fastest way, after you calculate the first one, just deal with the width, add to each and every one of them, and for the first one, you have to subtract. We are looking at the same question, and we need to come up with the histogram. When we draw histogram or ogive or polygon, as far as the horizontal axis is concerned, you may have some choices. In the case of an ogive coming up, and you'll see what it is, we really don't have a choice. We need to use the boundaries. So I suggest you stick with the boundaries. However, as you do the homework, whatever that they ask you to use. So the boundaries, you remember we came up with that as the following from the previous page. So you would use the boundaries or the limits or even the midpoints for your horizontal axis. For your vertical axis, you have a choice, either frequency or percent frequency. Which one are we going to use? We're going to read the question very carefully. It's asking for the frequency, whatever the question is asking. So the height or the vertical axis should be the frequency because the question says so. So when you do that, you keep the width the same. So 41.5 to 45.5, and then 45.5 to 49.5, all the way to the last one, which is 61.5. Or you could say 40 to 45, all the way to 61, or you can use the midpoint. As you can see, the first column has a height of 25. So look at this number. The second bar has a height of 14. The next one has a height of 7, 3, and the last one has a height of 1. So this is how you draw a histogram. It's a bar graph for a case like this. And on the horizontal axis, you can use the boundaries, the limits, or the midpoints. The vertical axis is the frequency or percent frequency. So finding the width from the histogram, if limits are given and you're finding it from the histogram, You don't need to add one. So it would be simply upper limit minus lower limit, or UB upper boundary minus LB lower boundary.
The following frequency table describes the speeds of drivers ticketed through a 30-mile-per-hour speed zone. A, prepare the cumulative frequency distribution. B, prepare the cumulative relative frequency distribution.
The concept of a cumulative frequency distribution, simply put, means start from the beginning all the way to the end. Therefore, when we want to write this, all of the upper limits remain the same, but the lower limits, we change them all to 42. So everything starts from the beginning. So the first class becomes 42 to 45, and the number of frequencies is the same, 25. But the next one is 42 to 49, which means we need to add the 25 to 14. The next one is 42 to 53, so we need to add all of those numbers, so on and so forth. Needless to say, n was 50. We had it before. So the lower limit changes to the lower limit of the first class. The frequencies add up. So this is 25, doesn't change, but this one, we do add them up. So we get 39. And then we add 7, and then we add 3, and then we add 1. And the last one must always be n or 50. Notice the last one must always be n if done properly. Now, as far as the cumulative frequency distribution is concerned, in some texts, they use boundaries, and the way they write it, it's less than 45.5. This one is less than 49.5, so on and so forth. So, and in some cases, they use the lower limit of the next class. They say it's less than 46. This one, they say it's less than 50. This is a better way of writing it because it's easy to understand the concept. Again, however the text is asking you, however the question is asking you, you want to follow that. This is one way to write that. We want to come up with the cumulative relative frequency distribution, the same thing, RF, you divide the frequency by the total size. So this column, each and every one of them gets divided by total size of 50. So 25 divided by 50, 39 divided 50 by 50, so on and so forth. Now, what is extremely important for everybody to understand are the following two rows. This one must always be n if done properly. This one must always be 1 or 100%, must. That is the last two columns. Now, we're going to use the same thing, and now we're going to draw what's called an ogive of the cumulative percentage distribution. And then what is it good for? We will look at the next part in a moment. So we are going to use the information that we have and draw an ogive. When you want to draw an ogive, as I said, the horizontal axis must be the boundaries. And the boundaries, we found them to be 41.5 all the way to 61.5. So along the horizontal axis, I don't want to call it necessarily x-axis because it may not be. So along the horizontal axis, you start with 41.5 at some point. It doesn't have to be at 0, 0 because it may not be. And then you go to 45.5, 49.5, all the way to the last. Now, along the vertical axis, what do you put in? First, you read the question. Either we go with the cumulative frequency or cumulative percent frequency. It depends what they have asked us. In this case, they have asked for the percentage. Therefore, this is 50%, 78%, all the way to the last. The last one is always 100% or 1, as I mentioned. The last one is always 1 or 100%. So let's do the drawing, see how that works. So along the horizontal axis, we put the numbers 41.5 all the way to 61.5. Then we have 45.5, 49.5, so on and so forth. Now, the Lower boundary of the first class will always correspond to 0 or 0%. The upper boundary of the last class always corresponds to 1 or 100% in the case of a percentage, or n in the case of a frequency. So I want to make sure everybody understands what this one is. This is the lower boundary of the first class, corresponds to 0 always. This is the upper boundary of the last class, must correspond to whatever this number is. If we are using percentage, that means 1 or 100%. This is 100%. If we go with the cumulative frequency, this must correspond to number 50, n. Be very careful with that. Then you go back to the first class. The upper boundary is at 50%. So that's why, take a look at 45.5. This point is at 50%. The upper boundary of the first class. Then the next one corresponding to upper boundary of the next class, 49.5. 49.5 corresponding to 78%. Then you have this point corresponding to 92%. You have this point corresponding to 98%. Now, what I want to add here is that these are line segments. Those are not curves, line segments. So what are they good for? Using the ogive, find the percentage of drivers who drove 47 miles per hour or less. So this is what it's good for. Along the horizontal axis, locate this number, 47. Draw a vertical line until it hits the curve, and draw a horizontal line until it hits your vertical axis, and then you read this number, which is about 60-61%. And your answer would be number 47 is somewhere between 45.5 and 49.5 on the horizontal axis, which corresponds to approximately 60%. Therefore, 60 to 61% of drivers drove 47 miles per hour or less. That's what the ogive can give us.
Given the following sample, the ages of 40 tenured faculty at CSULB, n equals 40 ages. A, construct a dot plot. B, construct a stem plots. A dot plot is a graphical display of data using dots for relatively small data sets where values fall into a number of discrete values, categories. Data values are plotted as dots along a horizontal scale of values. Equal values will be drawn as a stack of dots.
In order to go with dot plot, first course of action is to sort the data. Probably you can see that 32 is the smallest, 63 is the largest, and very carefully you sort it. Then you draw a number line. And on a number line, you need certain numbers such as from 30s to 60s. So you don't want to draw everything, but you can if you want. So over here, this is 35, and they are separated by 5. 35, 40, 45, 50, 55, 60. So this is in the 60s range, and this is before 35. Like this number, for example, would be 30, everybody. So this number would be 30, and so on and so forth. So here's what's happening. If we want 32, we locate number 32, and we stack how many? Just one. If we want 37, we locate 37, we just put one dot. 39, one dot. 40, so on and so forth. As you can see, When we go further and we hit number 47, then we have two of them. So we put two dots at top of 47. 48, 49, 50, we have one. 51, we have two, we put two dots, so on and so forth. So take a look at how it looks like. At top of 32, we have just one. At top of 37, we have one, all the way to 60, for example. We have, let's take a look at number 60. We have two of them. 61, two of them, 62, one, and 63, we have two of them. So you just stack up. This is how dot plot is used, and you can see the numbers. You can see the original data with dot plot. And clearly, the ages range from 32 to 63 years. Also, there is more tenured faculty at older ages. Older ages, we can see that. We're going to do the same thing here, but this time we're going to construct a stem plot with the same data. And again, the very first thing we need to do is to sort it. So we are looking at part B of the same question. And to find stem plots, we have to do the same thing. Sort the data, rank them from smallest to largest. It makes life easier.
Stem plots, or stem and leaf plots, display the data in order from smallest to largest. A stem plot, like a histogram, is a tool to help you visualize a quantitative data set. The name stem plot is because there is one stem with the largest place value digits to the left and one leaf to the right. We can see the distribution of data while keeping the original data values.
So as we look at the numbers, we see we have 30s, 40s, all the way to 60s. So the 10 digits would be 3, and then 4 and 5 and 6. So we will make up the digits, the 10 digits, 3, 4, 5, 6. So that's the first thing we do. Now going back to the 3, we have number 2, so we put number 2 here. We have number 7, we put number 7 next to it. We have number 9, we put number 9, there is no more. So next to number 3, we put those numbers. So if we were to read the original data, we would read 32, 37, 39. Now the next number is 4. What do we read? 40, 42, all the way to 49. So you have to write 0, and then 2, and then 3, 5, 6, 7, you have to put 2 of them. And that's the key. 7, you have to put 2 of them. So we put all those numbers and we repeated number 7 because the data said so. So if we are given this and we want to read the original data, we would read 40, 42, 43, 45, 46. And a reader should realize we have 47 and we have 2 of them. When we go to number 5, we put 0. 1, we repeated 2 times, 2, then 3, we repeated 3 times, all the way to 59. So notice what happens with number 5. We have a lot of those. For example, when you get to 9, 1, 2, 3 of them, notice we have 1, 2, 3 9s. You have to write them. So a reader comes across this, would read the following data: 50, 51, 51, 52, all the way to the end, that the reader will read 59, 59, 59. There are 3 of those. Coming to the last digit, which is 6, we have 0, 0, 1, 1, 2, 3, 3. So we repeat the 0, repeat the 1, repeat the 3. So a reader would read 60, 60, 61, all the way to the end. This is a stem plot. And again, the ages range from 32 to 63 years. Also, there is more tenured faculty at older ages. Clearly, we can see it from here and here. This is the longest one.